What's up, guys? How we doing? We are starting lab week to kind of break it up the mundane after break here. So here's kind of how this is going to look. We are going to say we're going to do this async day today. We're going to do some calculations. You're going to do a little reading, and then we're going to kind of go about doing the lab for the whole week. Okay. So there's two documents that you're going to need. First one is kind of this list of reactions that we're going to do. And this lab's great when we're in class because you get all these lab techniques and you'll be able to see me do a bunch of stuff. But for the most part, I would say this. I would say we're just going to use our calculation tools that we had um, for the review, and we'll learn a couple new things along the way, and whatever it might be. But basically, the whole purpose of the reaction is this: is you're going to take copper. We're going to start with copper. We're going to run it through a series of reactions. Okay, decomposition, double replacement, acid base, oxidation reduction, some stuff, and basically what we're going to do is we're going to get copper out. And the whole end goal is to say, like, hey, we ran copper through all these reactions. Here's what we got out from what we started to what we ended with. Okay, it's a great lab. I'm gonna film it because I think that's going to be more effective than watching me live because there's a lot of dead time. So to start, I want you to read through day one. Okay, it'll give you an idea what you're going to see tomorrow. All right. And then what we're going to do is we're going to do some of these calculations. So I will start you out on these. Okay. Um, here's kind of how we start. All right. Uh, you got the reaction. Copper is going to react with nitric acid, going to make copper nitrate, which is blue. You're going to have nitrogen dioxide, and then you will have water. All right. So what I'm going to start out with is 0.75 grams of copper. Okay. And here's what the calculation number one says. We want all of the copper to react and nitric acid be our excess. So we're going to prove this, okay, showing that, hey, we want all of our 0.75 grams of copper to react with, and we said we're going to react 5 mils of this in the procedure. We want to prove that that's the excess amount. All right, so limiting means like copper is going to run out, nitric is going to be your excess then. All right, so here's what you do. You set it up like this. All right, I'm going to do a couple of the harder ones that we might not know, and I'll walk you through these. Okay. So the first one is you want to do this. You want to say, okay, we're starting with 0.75 grams. We want to calculate how much nitric acid is going to be used. And we want to do that in moles. All right. So the first thing is this: set it up, but we don't need this last bracket. Okay, we don't need it because if we're start ending in moles, we don't have to go to grams. Okay, so that we just omit the last bracket. So 0.75 divided by its molar mass, and then we used our mole ratio. Okay, and what that ends up doing is that ends up saying, okay, you get 0.047 moles of nitric acid. All right, so now what we can do to put that in terms of a solution is this. We can use this molarity equation. And what molarity is it's moles over liters. All right, it's a way to express the concentration. All right, so we take that number, 0.47, we plug it in, okay, the moles. Now, we also said in our list of reactions that we are going to use a 16 molar nitric acid solution. All right, big M. Okay, so we're going to use 16 molar. So what we want to do is we want to solve for liters. And when you solve for liters, you get, so it's going to be so cross multiply and divide. So you're going to get 0.02, I think it's 9. Let me look. 9, yep, liters. Okay. Now, we want to convert that to milliliters, so we times it by 1,000 to get it to milliliters. And it's going to be 2.9 milliliters. Okay, so that to me proves since we're going to add, you only need to add 2.9, but we are adding 5.0 to make sure all of the 0.75 grams of copper reacts. Okay, so that we just proved to ourselves that, yeah, hey, that is the X that we're adding 5. We only need 2.9, so we want to make sure all that copper goes away. All right, so that's the gist of the first one. Okay. The next one says this. In theory, all the copper turned to copper nitrate. Calculate the number of moles that would be formed. Okay, so same thing. Start with 0.75 grams of copper. I'm going to go to moles of CuNO32, and I can skip the last bracket because it's in moles. All right, so you can do that one. That one's straightforward enough. So that's calculation number 1 and number 2. All right. Calculation number 3 is the second reaction. Okay, so now we got copper nitrate, which is a blue liquid. You'll see that, and we're going to add sodium hydroxide. All right, so we're going to use the amount, okay, of copper nitrate, and we're going to calculate how much moles of NaOH. Okay, so I'm going to take from calc number 2, I'm going to take moles of copper nitrate, and we're going to calculate moles of NaOH. Bam. Only need the middle bracket. We can omit both brackets on the ends because it's in moles to moles. All right. And then that's that. Okay. The next thing will be calculating the molarity. So molarity is moles over liters. All right. We want to calculate how much liters we should add. All right. So we're going to take this number, plug it in there. Let's see what the concentration of sodium hydroxide is. And it is 8 molar. Okay, so we have 8 molar, big M. Okay, we want to calculate, we know moles from here. We want to calculate liters, and then you can convert it to milliliters. Okay, so that'll tell you how much sodium hydroxide you need to add. And the last thing that we want to do is we want to figure out we want to use the moles of and calculate. We don't want to calculate the molarity. That's a misprint. We want to calculate the grams of COH that's formed. Okay, it's copper hydroxide because we're gonna make a solid. This is a double replacement reaction. We're gonna make a solid. We want to figure out how many grams of that we're gonna form. All right. So what you do then is you take your calc from number. You take moles of CuNO32. Okay, and I'm going to go to grams of CuOH2. I'm going to skip the first bracket because I'm already in moles. All right, this came from step 2. Okay, calc 2, just like we used this one. Okay, so I'm going to do that, and bam, you should have your calculations. Now, if any of that stuff was like, whoa, what in the world happened? Don't worry, we'll go over it. Okay, we'll do it. But some of you might be able to figure it out. Okay. This is for when we watch the video, remember? And then let me show you how to input it quick into your doc, okay? Now, when you want to input into your doc, let's say I got 0.75, 0.75 grams of Cu. I want to do this, okay? This makes a nice bracket. Insert equation A over B. Now I can type 1 mole of Cu over 63.55 grams of Cu. Then I can get out of it. And then I can do another one. Insert or new equation. Okay. A over B. It was 4 moles of HNO. And you can't do a subscript in here. Some of you might be able to figure it out. I can't remember how to do it. Over 1 mole of Cu. Okay. We close that bracket up. So there you go, and then you'll have your answer. So that's how you type it nice in there. Now, don't spend an hour doing this, right? I mean, try it, right? Try the calculations, try all this. We'll shore it up tomorrow, but at least want to introduce it because tomorrow when we meet, we'll talk about it. Then we'll watch the videos, okay? But outside of that, guys, hope you had a good break. Try this. Remember, don't have to hammer yourself over it but and it's okay to do it on a separate piece of paper first and then type it in too. Okay. Sweet. Hope it works out for you, and we'll talk tomorrow.